In this video we're going to talk a bit about exponents and the rules of exponents. Now exponents pop up whenever we're multiplying the same thing multiple times. For example, if you have 2 times 2 times 2 times 2, it's convenient to write this in a slightly different way. Since there are 4 of them, it's convenient to write this as 2 to the 4th power. And whatever the number is that we're multiplying multiple times, that's called the base. And the number of times we multiply it is called the exponent. And of course the number doesn't have to be 2. In this example the number is a, and we've multiplied it together 5 times, so it's much easier to write this as a to the 5th power. You're going to get into a bit more detail in class than what I'm going to get into, but I'm going to show you the basic rules for exponents. Let's start with an example. Let's say you have 3 to the 4th power times 3 to the 5th power. Since the bases are the same, they're both 3, is there a way that we can simplify this to make it look a little better? Let's take a look. Well, what is 3 to the 4th power? Of course, it's just 3 times 3 times 3 times 3. And we're going to multiply that by 3 to the 5th power, which is just 3 times 3 times 3 times 3 times 3. So we took 3 to the 4th, and we're multiplying it by 3 to the 5th, and we get a whole lot of 3's there. How many are there? Well, there are 9, so we can write this whole thing as 3 to the 9th power. And again, it doesn't matter what the base is. If we had b squared times b to the 4th, you could in your head think of this as b times b, and then b to the 4th is b times b times b times b. That's going to give you 6 b's all multiplied together, which can be written as b to the 6th power. So in reality, we're not going to write out this middle step here. We're not going to write out every single base every single time. We want to come up with a rule for how we can do this really quickly. And you may already recognize that rule. If your 2 bases are the same and you're multiplying them together, to get the result you can add the 2 powers. You'll notice that 4 plus 5 equals 9. And you'll notice that 2 plus 4 equals 6. So what we want to do is we want to write down a general rule that's always going to be true regardless of what the base is and regardless of what the powers are. The way that we do this in math can sometimes be a little bit ugly, but let's see what we can do. The rule is we have 2 bases that are exactly the same, and they're both raised to different powers. Now we don't want to put numbers in for the powers here because we want this rule to work for every single power. So what I'm going to do is I'm going to make this power m and this power n. And the rule that we just recognized over here was if you have the same base and 2 different powers and these terms are multiplied together, the result can be written as that same base raised to the power of the other 2 powers added together. Okay, so maybe that was a little bit wordy, maybe this equation is a little bit confusing, but just as another example, you could have now 2 to the 10th power times 2 to the 5th power, and we know that we can simplify that to be 2 to the 10 plus 5 is 15th power. It doesn't matter what the base is as long as they're the same base, and it doesn't matter what the powers are, no matter how big or small they are. You can always add those powers together for your result. Okay, let's box that rule up. Now let's come up with another rule. Let's say, for example, we have 2 to the 4th power, but that whole thing is cubed. Now what does that actually mean? Well, it means that we have 2 to the 4th multiplied by itself 3 times. So if we wanted to, and we certainly don't want to every single time, but in this example we can write out the 2 to the 4th, 2 times 2 times 2 times 2. We write that out 3 times. Now everything is multiplied here and every base is exactly the same. So what is the answer? How many of these do we actually have? Well, if you add them up, you actually have 12 of them. So we can write this as 2 to the 12th power. Now you can do several examples of this, and what you're going to notice is the same thing every single time. If you're raising a power to a power, what you can do to get the final power is just multiply the 2 powers together. You'll notice in this example that 4 times 3 is 12. And that's always true. So the rule in this case is given any base raised to a power, and that whole thing raised to another power is just that same base with those 2 powers multiplied together. Now I'll just give you one more example. You'll do a lot more in class. But let's say you have x squared, and that thing is raised to the 4th power. How can we simplify that? Well, we're going to use this rule. All you have to do is multiply the 2 times the 4, and you get x to the 8th power. Alright, so let's box up that rule, and let's write down another one. I'll just give you one more in this video, and then your instructor will show you the rest. Let's say we have a situation like this. Let's say we have 2 to the 7th power divided by 2 to the 4th power. Let's write out what that is. Alright, we have 2 multiplied by itself 7 times up here in the numerator, and we have 2 multiplied by itself 4 times in the denominator. Well, I look at this and I think to myself, well, I know some stuff is going to cancel. I can cancel a 2 from the numerator and a 2 from the denominator, and I can actually do that 4 times. So I've now canceled 4 2's from the numerator with the 4 2's from the denominator, and I can't go any further. There's nothing left to cancel. What do we have left? We have 2 times 2 times 2 in the numerator, and of course a 1 in the denominator, which we don't normally write. What is that? That's just 2 to the third power, because there are 3 of them. So do you notice a relationship between the powers on 2 that we started with and the power on 2 that we were left with? I think some people would notice that 7 minus 4 equals 3. And that is going to give you a rule. It works out like this every single time. So what we can write with this rule is, if we have the same bases raised to 2 different powers and we're now dividing these 2 numbers, the result is just the subtraction of the 2 original bases. So that's a to the power m minus n. As an example, if we have y to the 5th power divided by y to the 3rd power, the answer is just going to be y to the 5 minus 3 power. 5 minus 3 is just 2. So y to the 5th divided by y to the 3rd can be simplified to be written as y squared, or y to the 2nd power. Let's box up our rule, and let's get you a video quiz. We had 3 rules, so let's do 3 short problems. Good luck, and I'll see you in the next one.